textile machinery is what basically invented the whole profession of mechanical engineering. And, Complete University says the role of a mechanical engineer is to take a product from an idea to the marketplace. And this building is where an idea came into being in an actual marketplace and transformed, the textile business in all of America. So, it's kind of the temple of textile history here.
Hi, everyone. My name is Steve Guerrero. I'm the Director of Education here at the Charles River Museum of Industry and Innovation in Lowell. I'm really excited to see you out here, and I'm especially excited for tonight's talk. A little behind the scenes look. I got to spend most of my day talking and geeking out about some interesting early textile history. Met our tonight's speaker in Dedham at the Mother Brook condo complex, where we saw a Harris Corliss engine from 1879 in, I would say, pretty beautiful shape.
Wonderful shape.
And then we spent the afternoon around the museum, and tonight we get to hear about power loom technology. I originally asked Mac to come up here when I heard him speak at the Textile Forum in Vermont, and we have, you might have walked by here at the museum, a Markham reproduction loom. And when I first started here, some folks had said that that's a reproduction of the loom that Francis Cabot Lowell was using. And Mac would say,
no.
And we've also been kind of sharing, and you may have heard other stories about Francis Cabot Lowell going to England, researching power loom technology over there, maybe going to the textile mills in disguise to sneak some information.
Embarrassingly bad.
No. Or you may have heard the myth of Francis Cabot Lowell memorizing all the loom parts and reproducing them from memory when he got back.
Heroic if true.
Big if true, as they say. So tonight we're here to really get into the mechanical knowledge that built the American Revolution at scale from right here at the Boston Manufacturing Company's site. The Charles River Museum is a National Historic Landmark District. You are at the site where the Industrial Revolution in America scaled, where the model for domestic manufacturing was built, and where some really important developments in labor history, labor rights, the first industrial labor strike, as well as textile and industry manufacturing at scale happened. Tonight's speaker, aptly named Lowell McKay Whatley, or Mac as we call him, is Director of Local History and Genealogy Resources at the Randolph County Public Library. He had practiced law for 30 years, a graduate of Ashboro High School, Harvard University, UNC Chapel Hill, and the Central School of Law at North Carolina. He worked as an archaeologist for the state of Virginia, an architectural historian for the state of North Carolina, and mayor or commissioner of the town of Franklinville for more than 30 years. He's also more recently interested in developing a textile mill historic site and has one heck of a collection of looms down in North Carolina. And I'm especially grateful to independent scholars like Mac that have kind of an interest and intellectual curiosity that he has pursued with integrity and with a real passion that it makes me very grateful to have him here to speak. Without further ado, I really want to be especially happy, geeking out, excited, intellectually curious to hear what Mac says. And I will be taking notes because I have a feeling we might be adjusting maybe some of the public interpretation that we do around our early loom technology. And without further ado, Mac, come on up.
Thank you. Well, I really appreciate Steve inviting me here to do this talk. It's not the same talk as I gave at the American Textile History Forum with Rabbit Goody back in Vermont, but it keys off it and it underlies a lot of what I said there. A lot of it started here when I was at Harvard, and one of my professors, John Coolidge, got me interested in textile history, especially Lowell, and I got to know the people who were involved in it, especially the people at what was then the Merrimack Valley Museum, Textile Museum, and Larry Gross, who was the curator of industry there, and hung out with him and looked at their big warehouse of machinery, which the museum had started to collect since, 1957, Claire, or something like that? Yeah, Mrs. J.P. Stevens started that mill, and it was the place to go for textile history, whether it was the archival collections, the library that Claire was the librarian of, or the mechanical history collection, or the costume collection, the swatch collection. Unfortunately, now scattered all over the United States, and this part ended up in North Carolina, because I was the chairman of the collections committee when the museum decided to dissolve, and they wanted to just take a lot of pictures, the trustees, take a lot of pictures and send it all to the scrap metal dealer. And I wouldn't let that happen, so I ended up being responsible for 30,000 square feet of machinery in a warehouse, which is all kinds of textile machinery, all grades of everything from 1792, which I believe is our oldest artifact, up to the 1976, which I think is our newest, our last Draper loom. But it would make a real museum curator run screaming out of this building, because it's not air conditioned, it's not heated in the winter, there's mold and mildew and stuff on the leather. So I make no apologies. All I can say is that at least it still exists. And it's the only large collection of American-made textile machinery in the United States. And that's all I can say. But how this started, besides the fact that at one time I asked Larry, what's the oldest loom in your collection? Because I was interested in weaving technology. And Larry, we went around and looked at different things, and none of them were very old. 1855, I think, is the oldest one that was in the American Textile Museum collection. And there's a reason for that, because now all power looms are made in other countries. These are the #1 manufacturers now. But in 1895, there were at least 18, maybe more, 24 companies, mostly in New England, who made looms as part of a textile machinery output. These are Whiten looms from Whitensville, Massachusetts. That just happens to be a weave room in my town in Franklinville. So in 1895, there were that many American companies making it. But the Draper Company in Hopedale, they cornered the market. In 1892, they cornered the market in plain loom weaving, because they bought a British patent, a Northrop battery there, the revolver, the round battery there. That's called the Northrop battery. That on the Draper loom meant that it could automatically change the bobbins in a shuttle when the shuttle ran out. So weaving happens when the shuttle is knocked back and forth by the picker sticks. The picker sticks are over here on each side, and it just goes back and forth, the shuttle. So the shuttles are automatically changed by the Draper battery, because when the bobbin runs out of yarn, there's a little hammer in the mechanism that knocks the bobbin out of the shuttle onto the floor in that box, and then this battery rotates, and another one, the hammer knocks another full bobbin in. So there's I think 18, maybe 24 bobbins in the revolving thing there, and so it can go a lot longer. Before then, the weaver had to mechanically stop the loom when it ran out of yarn, put a new bobbin in the shuttle, start the loom again. And so that's why a weaver up to the 1890s could only look after so many looms, because she would be running back and forth, trying to make sure that everything was still full of yarn. So this changed everything. The Draper E-models are what they have at the boot mill weave room still today. Those all came from Kingsport, Tennessee, a mill that I helped them find. Because of that innovation, almost all the other companies stopped making looms. The Lowell machine shop, started here, stopped making looms in 1912. It just wasn't economical anymore. And so this is the only Lowell machine shop loom that I know of still in existence. It says it on this is called the arch of a loom, and it says Lowell machine shop. Frustrating to me as a museum person. Larry Gross knew this story and told it to me. This very loom the boot mill got it from Greenville, South Carolina. That was at the Sacco Lowell Company ended up in Greenville, South Carolina from Massachusetts. And they had this, and it was on display down there, but it was painted white with gold trim. And when the Park Service got it, they couldn't figure out why it was white with gold trim. And so they painted it green with red trim. Well, it was white with gold trim because this was the loom that was exhibited at the World's Columbian Exposition in 1892. And that was the Great White Way, and everything was white there. So you pass this on the way in. It is a really accurate reproduction of, I think, this drawing, which is in 1827, or a drawing of a loom that was made by the Lowell Machine Shop in 1827. Now, this drawing, this is at Harvard Business School, the original, but it was published in 1933, and it actually is by a J.M. Bement, B-E-M-E-N-T, who was the chief engineer and draftsman of the Sacco Lowell Company in the 1880s. And he has a drawing of the loom in this loom in 1827, and a drawing of the loom in 1855. And those are illustrated in his article in 1833. So you can see how closely this tracks that drawing. And so I got to say, it's a great illustration of that drawing, which is, by all accounts, what the Lowell Machine Shop was building in 1827. But is that the loom that Francis Cabot Lowell and Nathan Appleton built in a loft in downtown Boston? I don't think so. So if that's not what they built, where is what they built? And that's what I asked Larry many years ago. And nothing survives that is a drawing or a specification of the loom that Francis Cabot Lowell built, or the other loom, the competitor loom that William Gilmour of Rhode Island built. Because in 1836, the United States Patent Office had a horrendous fire that destroyed all the patents that had been done between the 1790s and 1836. They tried to reconstruct them. They put in the newspaper all, if bring your patents in, we'll re-record them and all that kind of stuff. So people who were still making money off their patents did that. But people who the patents didn't matter anymore didn't do it. So the Francis Cabot Lowell patent by 1836 was so outdated by improvements, as we'll see, that they didn't bother to re-record it. So how would we find out what it looked like then? The only way is to what's called reverse engineering. Software people do it all the time. They get a circuit board and they look at the capacitors and the ICs on it and stuff like that, and try to figure out what's it doing, what's it for, why do we have this? Why do we have it instead of something else? So experimental archaeology does the same thing by taking the oldest thing you can find and trying to figure out what was an older version of it like. Because a loom does the same thing. You know, everything a loom does, even a modern loom, even the ones that now run 1,200 picks a minute, it does the same thing people have done for thousands of years with their hands and feet and fingers. So there's only so many motions that it takes to weave. And the interesting thing to me, I was telling Steve about this, that I mean, mechanical history, you know, since the 1730s in England, mechanical history has been a process of inventors trying to figure out how to replicate the motions of hands and fingers and feet in weaving and spinning to do it with a machine faster. So that's what I'm talking about when I'm talking about reverse engineering. So to start with that, we got to find the oldest something that we can go back to. So in the American Textile History Museum of sad memory, we have that in our collection, which is now in North Carolina. We have these two, which are, I think, the two of the oldest ones. We have pieces that might be older, but these are whole. So this is a Furbish loom made in Philadelphia, I think. And this is a horsehair loom. Two radically different types of loom, because this is a shuttle loom that goes back and forth with picker sticks. This is a rapier loom, which has a little thing that goes across on a like treadmill thing and grabs a piece of horsehair and brings it over and over and over. Horsehair was like the upholstery fabric of choice in the 19th century. And we have three of those. But older than that, though, are the looms in the Watkins Mill Historic Site in Missouri. And they were photographed by Jet Low back in the 60s. They're looking better now. This is a state historic site, but they don't run. But this is a Jinks, Alfred Jinks, who was from Rhode Island but moved to Philadelphia to run his business. This loom is about 1855. Oldest looms in England, I looked at those. So these are there's four of these. They're in four different museums in England. England has a wonderful catalog of textile machinery and museums. It's called the National Registry of Industrial History. We need that in this country desperately. One interesting thing about these looms is they, instead of picker sticks on either side, they have one in the middle that goes back and forth and back and forth. Modern English looms have gone to picker sticks on either side, but they're up here, and instead of going like that, they go like this. So, and that's the English standard. American never used it that way. Then the oldest looms in Canada. I went to this historic site, the Asselstein Woolen Mill, which is at Upper Canada Village, a wonderful place. You ought to go there. And the oldest Canadian-made loom is this one, Cont Gorley and Company from 1870. It's not on display. It's in the attic of this mill because it's not on display because it's older. 1870 is older than their interpretive period, which is 1868 when Canada became an independent commonwealth. I told them they needed to get it out because, So the other two looms they have there at the Asselstein Mill, there's a wide loom and a narrow loom. So the wide loom, there was a study done by Larry Gross and other people in the 1970s, and this loom here, they couldn't figure out what it was because the arch is gone. It broke, and they replaced it with this piece of wood. So it's just kind of an in-house repair that they made just because all the arch does is basically keep the harnesses up and down. But here on either side, you see these braces. Well, it's the exact same braces over here in what was identified as a furbished loom, 1868 furbished loom in the Watkins Mill. So it's easy to identify. What's called the narrow loom, though, they didn't know what it is. It has no identifying marks, but you know, this is it. When Diane Fagan Affleck went for me and took a picture of it because I couldn't get there, and so it looked like that about 10 years ago, and it looks like this last summer because they have woven something new and better on it. It doesn't run because it's missing some parts and stuff, and it's also been heavily modified because it's modified to have the side picker sticks like other American looms, but really there's a bolt hole right there where it used to have the center thing, just like the English loom I showed you. So this struck my curiosity because it's so much older looking than any other loom in America that I could find, particularly because of what's called the center picking. And so I started looking for who could have made it. Found this patent motto in the Smithsonian Institution. It's an Elijah Fairman patent from 1838. According to their records, he applied for it in 1835, and they didn't get around to issuing it until 1838, probably because of the fire. But you see, it's got that center picking motion down here. It's got that same strange arch, a wooden arch there. And then you can ignore this because his real patent was, this is his drawing. What he thought was his innovation, his money maker, was this strange harness changing motion here. And then as a sort of side thought, he put this in. Well, this turns out to be the mechanism, a side cam operation that everybody liked and became the standard harness mechanism for all satinette looms. Satinette was basically what colonial people would call linsey woolsey, you know, with a linen warp and a woolen warp linen. No, yeah, linen would have been the warp, the strong part, and wool would have been the back and forth. So anyway, so this is that. So this is so similar to that loom. I'm thinking it's got to be this guy, Elijah Fairman of Staffordville, Connecticut. So I did a lot of research, and that's what the whole talk was about that I gave in Vermont at Rabbit Goodies thing. And you know, to figure it out, I did the whole company history of this in Connecticut and everything that they went through, and it became what's called the Stafford loom, and the Stafford loom still was made into the 20th century in different forms. But you know, the important thing in his patent turned out to be this, not that. But this whole framework turned out to be very popular because there were at least 6 other patents. So what I should have said, in his patent application, he says his patent is not for a loom. His patent is for these harness mechanisms. That the loom he's attached his harness mechanisms to is the loom in common use. That's what it says in his patent. So there's 6 other patents that use this almost exact same shape. And so obviously the loom in common use looked a lot like this with various changes. Because all these inventors were patenting, you know, improvements and different kind of gizmos. See, this is a pattern chain kind of thing up here, and then there's something back here, an improvement for that. But see, this one is actually using the side cam thing. So I mean, the satinette loom at any rate in Connecticut was, this is the loom in common use. So, oldest American-made loom, I got to say, is this one in Canada. So if this is our starting point for reverse engineering, how do we do that? So I went to Canada and I tried to copy it. You got to do things like count the teeth and the gears and stuff like that. And I got to say, it's not easy. I mean, because it's a real machine. It's not even running, but it took me 4 times to get a count that agreed twice on how many teeth were in a gear. And then you don't know, the dimensions of it exactly and stuff like that. So it's hard to look at a machine, let alone a moving machine, and say, this is how it's working, and this is how many teeth it has, and this is what I need to do when I go home. So I'm getting ahead of myself there, but I mean, so if the loom in common use in 1835 looked at the Fairman loom, then if there's a genealogy of it, which that's what I do nowadays is help people with their genealogy, well, machines would have a genealogy too. And so all power looms go back to Edmund Cartwright, who invented the first one in 1785. And and then I'll talk about him later, but in the United States, there were 2 branches. Just like a family moves from England and gets married and has children, and then there's all kinds of family branches. Well, so you had the Francis Cabot Lowell. Everybody who was his friend or family called him Frank. But his wife and all her correspondence called him Mr. Lowell. So anyway, Frank Lowell's loom is the one that they used in this building at the far end of this lineup. But then the competitor loom was the one that this man, William Gilmour, was brought to Rhode Island and invented in 1817, 3 years later. And partly that was because the Rhode Island people, once the Lowell loom got going, it was patented. And the patent fee was like $300, I think, which was a lot of money back then. And so they paid William Gilmour, the manufacturers in Rhode Island, they paid him $1,500 to design a loom according to his specifications, and they didn't patent it. So we would call it, of course, nowadays open source, which meant that everybody copied it. And so it became, as far as I'm concerned, the loom in common use, because it was free to copy it. Now, it wasn't easy to copy it because the Gilmour loom had an iron frame, a cast iron frame, so you had to make patterns and all that kind of stuff. And it was a different family, and we'll talk about that in a minute. So the question then becomes, does the Fairman loom, 1838, exhibit a family resemblance to the Lowell loom or to the Gilmour loom? So you got to go back to the beginning of weaving history, and it also starts in 2 places, Scotland and Lancashire in England. So Scotland started with this machine, which is a ribbon loom. They called it an inkle loom that the Dutch weavers had been using, and it made, see, all these are ribbons. There's different ribbons, and so it would make a lot of ribbon at once. And you could, it was powered by turning a crank or sometimes with a dog on a treadmill. So that is what the kind of loom they were using in Scotland in the 1770s. But then this guy, Edmund Cartwright, who was an Oxford-trained cleric, Anglican cleric, he bet somebody that he could mechanize the weaving process in the same way that Arkwright had mechanized the spinning process. And everybody says, you can't do that. So he went off and started, and he came up with this, another crank and things. But it's very odd because it operates vertically instead of, all the looms that we're familiar with now go longitudinally. This one goes up and down in a very strange way, and you can't look at the patent and figure out how it does that. Oddly enough, there's 3 other people in America that tried to make a vertical loom. John Thorpe in Fall River was one, but he had never seen an actual loom in operation. He's an upper class British guy. They didn't do hand weaving at home. He was above all that. So he had never seen a loom actually weave. So he said, this is what he thought. And I think he says, it just came to me. Well, I think it came to him because in Oxford textbook, 1725 Oxford textbook, this is a Greek and Roman loom off of a Greek vase. And so clearly, to me, that's what he was thinking of, whether it was subconscious or something else. But anyway, it didn't work. It was really bad. So he went back to the drawing board, and in 1786, his second try at it looked like this, which is, here again, almost like what we're looking, like a barn loom. It's called a barn frame loom. There's another one out there in the hallway. So these are all his different motions. This is from his patent drawing, and he's showing how it would work. The only weird thing compared to a modern loom is this. Well, to make the yarn strong, the warp yarn strong, you see the warp yarn is what goes back and forth there. So it starts here off the creel, goes through here, it goes up there, and then winds on a beam up here. Well, there's a lot of stress on the warp yarn because it's being pulled and then it gets hit with the lay, and so it's hammered back and forth. And so warp yarns tended to break unless you did something to them. And something that they did to it was paint starch on it with a paintbrush and let it dry, and that strengthened the warp yarn. Well, that's what this is. You can't see it. It's shown back here, but it goes up and down and all around through troughs of starch. And when the yarn comes out there, you can't weave right away because you got to let the starch dry because you don't want to get it all over the rest of your loom. So it was cumbersome, but it worked. But not very well because all this stuff here. So that was, even though mechanically from the invention of mechanical engineering, this worked. It's just basically mechanized a hand loom. To make it go fast, which was the whole point of mechanizing it, you had to do something about what's called the slashing process, which is putting starch on the warp yarn. So all the motions that he devised are hand weaving motions. So shedding is what the warp yarns are coming this way. Shedding harnesses up and down to make a hole in the middle of the yarn so that the shuttle can go through. Picking is knocking the shuttle back and forth across the mill with the stick. And then beating up is where the lay hammers against the new shed there that's made, that the shuttle has made, to tighten it up. So it'll be loose, and then it's hammered and it's tightened up, and then the beam rolls around and the shuttle goes through and it tightens up and stuff. And all this is happening even in a hand loom. It's happening 60 times a minute. A good hand weaver, maybe 75. So secondary one is the let off. You can't keep pulling on the warp yarn because it'll break. So you've got to, the warp beam's got to turn somehow every time you're doing this, or else it'll snap. So that's called the let off. And the take up is you got to keep tension on it. So the take up reel in the front has to keep turning too. So that's got to move. And then the stop motions, if the warp yarn breaks, you need to stop the loom. if the weft yarn, if the shuttle gets caught, you got to stop the loom because that breaks the threads. And then the reed stop is a different kind of a shuttle protection because if the shuttle stops in the middle of the pick, it'll just keep beating against the shuttle until the whole loom is messed up. So anyway, those are every loom does those things in different ways, but that's what they had to be looking at. So in what I call the wiper family, that's what they call the cams in Scotland. The wiper family was mainly developed around Glasgow. And so this is getting ahead of the story, but when the Lowells went on their grand tour of England, their headquarters was in Edinburgh because all their friends were in Edinburgh. So this is New Lanark, which is the Robert Owen, special mill down here. And then all these other Paisley, Johnstone, Pollockshaw, and Milton. Remember those because those are all important. So this is the very first weaving mill in Scotland, and then these three, the next ones. So the wiper loom, they called them, in America we call it cams. Britain calls them tappets. Everybody's got a different term. You got to figure them out. But the cams convert rotary motion into linear motion, linear or oscillating. So this 1813, this is what the Edinburgh Encyclopedia said this is what a wiper loom looked like. You see, that's the cam right there. It turns around and it makes things go up and down, just like this. So this is the wiper loom as published in the Repertory of Arts, which is the annual magazine that published all British patents. So this was published in 1798. Robert Miller was assigned the patent. He was the guy who ran the mill at Milton, which is, I showed you there on the river outside of Glasgow, Milton Print Field it's called. And so this was published in this book, and this book was available in the United States. And in fact, it was in the Boston Athenaeum, and was given to them in 1807, the whole set and of course, Francis Cabot Lowell was a founder of the Boston Athenaeum, as was Nathan Appleton and everybody else. So anyway, this was available. This was published, a better illustration. This loom, from the Miller loom, was modified and improved and taken to a mill at Pollockshaw's. I showed you that on the map south of Glasgow. That was run by this guy, Monteith. And this is what that loom looked like in operation in the Pollockshaw's mill in Scotland. So you see it's very similar to the Miller machine. A few changes, but basically it's, this wooden frame, the batten is hanging down, the harnesses are hanging down. It's got the center pick there. So that's what that looked like. Well, so that was illustrated in 1846. 1851, one of the same looms was sent to the Great Exhibition in London and the Crystal Palace. Never made it there because during transport, the place it was stored burned up. So anyway, but it's in their catalog. So this is it in the catalog. And you see, one of the things you can see clearly about it is, besides the frame and the wooden, is this. That's a spring. It's like a car spring, it's like like under your car. And that's what returned the lay. A cam made the lay go forward, And then when the cam let off, the spring is what made it snap back. So that's why it's called, it didn't have a positive motion. It only went one way, and then it had to be returned with the spring. So that's the difference in what's called the crank family. The crank family is the loom that was developed in Lancashire. Now remember, all these two families both came out of Cartwright. They're just like different inventors looking at the original Cartwright machine and taking it one way and this family taking it another way. So Lancashire is here. Manchester's the main town. Stockport, though, is the important part for all of weaving. Now, this is Belper, is where the first Arkwright mill was down here, and that's where Matlock is the spa that Cartwright was at when people bet him that he couldn't do the Arkwright thing. So he developed it, and an engineer, well, they called him a machine maker in Manchester, who used to be a clockmaker in Manchester, helped him build it. And he took it to Doncaster, which is where his wife had a lot of property. And the first weaving mill, Cartwright weaving mill, was in Doncaster. Okay, then he sold the right to make looms to this company in Manchester, and they made 500 of them in Manchester in 1792. And before they were 6 months old, the weavers in Manchester burned the mill down. And that terrified the mill owners in Lancaster about weaving, mechanical weaving, power weaving. And so it became a big secret after that. And so that was 1792 when the fire happened in Manchester. But then it's not till like 1802 that loom inventors come out of the closet again. So, for a good 10 years, inventors in Lancaster were scared of showing that you could do mechanical weaving and make a living at it. So they just went underground. And the guy who, how that looms, and a crank, of course, a crank loom actually has cams. So it's just not one or the other. The crank loom actually has cams and a crank. So, a crank is, it can be a crank like a windmill or an egg beater, that you turn like that, or it can be just a crankshaft like this. This is the crank, and so when you attach something there, instead of being a circle, it's going to be like that. So the crank does some of the things the cam does, but instead of stopping, doing it once, and then you got to have the spring to return it, with a crank, it goes that way and it goes that way. It goes that way and it goes that way. And so this is much more efficient. The guys in Lancaster who were working on that, one was William Radcliffe, and he didn't believe in power looms as much as hand-assisted looms. So he invented this thing called a dandy loom, which actually, and later on had an iron frame, but it's basically a hand loom. And we basically call it a Hattersley loom nowadays. That's what they would use to weave tartan and tweed in Scotland. So it's the same. It's just not hooked up to any kind of machine. So there was that. But then Radcliffe and his engineer Johnson did one better thing, which made everything click, which was he invented a warper, this machine, this is the patent drawing, and a dressing machine, which we would call nowadays a slasher. And these were what they needed to paint the starch on the warp yarns. And so this machine did all the warp beams and put the starch on them and dried them before you put them on the back of the loom. So it created an extra new process in weaving that made the weaving go faster because you didn't have to wait for the starch to dry. So this was actually the machine that made power loom weaving economical. So then William Horrocks, who is the guy in Stockport who came out of the closet in 1802 with a loom design that was very efficient and used pieces and parts of other people's stuff, but it's the first one to be marketed by companies. And you see right here, this is an ironmonger. They were in 1812, I think. They were selling this. This is one of his design looms, so I don't know why that one is upside. Well, both these are kind of upside down. Anyway, I've shown you these before, but this is the Miller loom. This is the Cartwright loom. This is how they addressed certain motions. And so it turns into the Pollockshaw's loom there. And then the Horrocks first one in 1803, his first patent, looked a lot like it except simpler. And it was a wooden frame loom too. But 2 years later, and this is more of his patent drawings, 2 years later, he's improved it and has an iron frame on it. And then 2 years after that, it looks like this. And so this is a model in the Helmshire Museum in England. This is a Horrocks loom, and it's kind of a early hybrid. It's got parts of 1803 and parts of 1813. So you can tell he's still trying to modify his design, but he's heading for that. This is his 1813 patent. And this is the machine that turned the British weaving around in Lancaster anyway, because this is what everybody started using in Lancashire. Still in Scotland, they were using the Pollockshaw kind of loom. So what's going on then is there's similarities on this, and it's the similar to the Fairman model and the Esselstein. So you got this kind of crank. It's very similar. Fairman and Gilmour designs are and Horrocks, because Gilmour studied with Horrocks and in Scotland, so he knew all the designs. So basically, the way it's coming out is that the Fairman loom is very much like the Horrocks loom, and the Horrocks loom is the one that became standard in England. But it's probably not the one that Francis Cabot Lowell could see when he was in England. This is he and his wife. They went on a spa vacation. They went to every single spa in England. I think their favorite place in the United States was Ballston Spa in New York. And that's where people went to recover their health. They said, I shouldn't be funny because they both died very young. They both were in their early 40s when they died and left four children. So they were sickly, evidently, and their reason for going to England was to visit the spas and recover their health. But all the literature has a really strange sort of attitude about him. Francis Cabot Lowell, he's a pirate who went to England and stole their most precious commercial secret with pirated plans of Cartwright's loom, which it wasn't Cartwright's loom at all. He's a spy, he did industrial espionage with his photographic mind. He's a thief, he stole the British power loom design, and he's a superhero because he memorized everything just from seeing it once. So, I think we're selling him short by making him a superhero like that, because he was, by all accounts, a mathematical genius at Harvard, and was recognized, as that by lots of different people. what we know about Francis Cabot Lowell, though, basically comes from Nathan Appleton, who is one of his business associates, who was visiting England with his new wife in 1810 and met them in 1811 in Edinburgh. And that he's the one that said, Francis Cabot Lowell told him, oh, I've decided I'm going to replicate, all of this machinery and bring it back home and do that in Boston. So almost everybody has said that he got his design from Lancashire, and it was the British loom that he copied. And this is something written by this guy Mallieu in 1958. It's unfortunate that so much information on the Boston Manufacturing Company has been derived from Appleton's pamphlet, since much of it is inaccurate. And I got to say, so did he visit the factories in Lancashire? There's very little. We've looked at all of his correspondence in the Massachusetts Historical Society. There's almost nothing in there that even talks about visiting factories. What he does say, though, he writes to his uncle, manufacturing towns are very dirty and the people are jealous of strangers, particularly Americans. But the Scottish people were very nice to him and warm, and he loved them. And of all the places we have been in, we admire Edinburgh the most, and his people are as attentive as the French and have as good a morals as the English. So their contact there was this lady, Anne McVicker Grant. She was a poet, and she's a recognized author of 3 different books on the Highlands of Scotland. She grew up in America. Her father was a Tory supporter and had to leave America. He was part of the British Army, actually. And so she moved back to Scotland and married Mr. Grant. And so she was the landlady of Francis Cabot Lowell's brother, Charles, when he spent 5 years in Edinburgh in divinity school. And then because of that, his brother John and his wife went and stayed with her, his sister Rebecca. So the whole family knew Mrs. Grant. And she loved them even after they left. There's more than half the letters in the Massachusetts Historical Society are between them and Mrs. Grant. So there's one letter, Hannah Lowell to her mother says, Mr. Smith was very good in showing us the town manufactories when they went to Glasgow. And for most people, that's been a throwaway, because they said, Mr. Smith, how many Mr. Smiths are there? Well, if you look into Mrs. Grant, William Smith was the son of Mrs. Grant's best friend, Isabel Ewing, and his father, the husband of Isabel Ewing, was Archibald Smith, the chairman of the Chamber of Commerce in Glasgow, and one of the richest men in Scotland, who was also a Tory who had grown up in America and had to move to Scotland. I mean, I think the Lowells knew all those because they were all but Tories themselves. They just didn't leave. But they knew all those guys in England and they visited them. So this was part of his center group of friends. And so William Smith's father was a stockholder in 2 of the mills in Scotland that were weaving. So this is his father, and that's his mother. And so they were the ones that I am certain, they're the ones who showed that Francis Cabot Lowell could get in the factory and look at what was going on. And what did they see there was the Scottish looms. So if you do a lot of research into weaving history like I've done, so in 1813 there were 2,400 power looms in Great Britain, 1813. 1812, Sinclair says there were 1,560 power looms in Scotland. The vast majority of the 2,400 of them were in Scotland. So there were a dozen weaving mills in Scotland, and there are at least 10 in Lancashire, but they only had 840 looms. So the other reason that the people in Lancashire weren't too friendly is because the Luddites were happening at this same exact time. In the of 1811 was when the Luddites started attacking mills all over Lancashire and busting up the looms and trying to set fire to the factory and attacking the mill owners. So this is a list of all the mills that Francis Cabot Lowell could possibly have visited to see looms weaving in Scotland and England. And it may look cut and dried. I can tell you it was a mountain of research to figure this out. And I got documentation on it. But you see, those are the 12 weaving mills in Scotland. There's one in Wales, which was actually the only one that probably was still using Cartwright looms. And he could have been there because he went straight through this town, Llangollen, on his way to Ireland. But he went, Milton is on the way, is the oldest weaving mill in Scotland. It's on the way to Loch Lomond. You know, the Grand Tour, everybody was going to the Lake District and Loch Lomond and stuff like that. So you have to go through Milton to go to Loch Lomond. This William Smith, he was a stockholder in this mill, and this mill. And all these other mills, you know, they're all within, you know, a day's travel by foot or horse of Glasgow. Now, these mills over here, these are all the mills that I can find in Lancashire, most of them in Stockport. But the hard thing about researching these is that so many of them went bankrupt very quickly and then changed their name. So a lot of them have been known by more than one name. But the Horrocks Mill, you know, they were forced into bankruptcy by this guy who was their factor, Goodair. But when the Luddites came, Goodair was the owner and not Horrocks. But this mill got trashed by the Luddites. Peter Marsland in Stockport was next door to the Horrocks. It got trashed. This one did. Goodair's mill in Chorley did. I mean, the Luddites, 9 out of 10 mills in Lancashire got trashed in 1811 by the Luddites. So obviously they were not going to be friendly to Francis Cabot Lowell, who just sort of wanted to wander in and say, show me all your weaving, you know. So I don't think that happened. So what kind of machines could he have seen on his trip? He definitely could have seen that. He knew the stockholders and the mill owners, and they were very friendly to him because he was the same as them. I mean, they were you know, industrialists and retail wholesalers, and he could have seen the Horrocks looms if he could find anybody to let him see. But you see, you know, he could have had a lot of time to look at this and probably not much time to look at that. And then it's made out of iron, and you know, you got to have patterns for that and stuff like that. So then you got to say, well, he came home and he and Appleton went in the attic of Appleton's store downtown in Boston and invented the loom. And he says, you know, but people didn't believe that even then. That's what I was saying here, that people who worked in this factory and quit and went off and started their own factory said, he didn't really invent it. He got it out of a book. But also, you know, this is the only representation of it, and it's on the seal that they developed in 1813, and he showed this a mahogany model of his loom. He showed it to the stockholders at the very first organizational meeting of the Boston Manufacturing Company. And you know, could it be just plain old barn loom? It could be, but except for this. I think this is another one of those springs. You know, I showed you the spring that was on the Cartwright machine and the Miller machine. I mean, looks a little different, and you can't tell because it's such a crude drawing. I mean, this is only about 1.5 inches. But anyway, he got a patent for this machine in 1815, and but I think it looked like this because this is what his contemporaries thought he cribbed is this machine from that book in the Boston Athenaeum. And I think it looked more like the Pollockshaw's loom. You know, could he do it? I mean, the question in my mind about Nathan Appleton and Francis Cabot Lowell, these were wealthy men, some of the wealthiest men in America at the time. These are guys who had people to help them get dressed in the morning. These are not guys who like go out to the workshop in the back and, you know, whip out, you know, a complicated machine. They've got to have help. So it's interesting that even though there were patent lawsuits against the Boston Manufacturing Company by half a dozen different people, but none of them were against the loom. Nobody ever sued about the loom infringing somebody else's design or something like that. So who did it if they didn't do it? Well, Paul Moody came after the loom was designed and presented to the board of directors. He was hired maybe 2 months later. And when he started, he was paid $1,500 a year. Patrick Tracy Jackson and Francis Cabot Lowell were reimbursed by the company $5,000 to $2,500 apiece for their work in designing the loom. Well, Jacob Perkins is somebody we got to talk about, because he's the guy that Francis Cabot Lowell and Patrick Tracy Jackson tried to hire to run everything, build everything, design everything. He did design the dam down here, but then he said, I'm busy, I got to go to England and stuff like that. So he didn't do any other stated work for the company, except that, and he was paid $7,400 for that. Good money in 1813. But then he was also paid privately almost $6,000 by Lowell and Jackson for aid and assistance of his talent and knowledge in subjects connected with the undertaking. So a consultant fee. Consultants then is now made money. But then another really odd thing is Francis Cabot Lowell personally paid Perkins $14,500 for 4 patents that Perkins did: a water pump, a fire engine, a screw cutter, and a vault lock for banks. Well, one of these, the screw cutter, ended up being a lawsuit against Francis Cabot Lowell because another inventor said, hey, that's my screw cutter. So that wasn't worth anything. And none of these they never, as far as I can tell, Francis Cabot Lowell never used the water pump, the fire engine, the vault lock, or anything for any reason. So Jacob Perkins is paid almost $28,000 by Francis Cabot Lowell and the Boston Manufacturing Company, which, $1 in 1813 is worth $20,000 in 2025. So that comes out to about $300,000 in today's money that they paid him for sort of nebulous work. I'm conspiracy theorist, maybe, but I think that they paid him to design the loom, so that, and then let them patented it, and it was worth that much to them not to share the patent. The patent was assigned to the company here. So he was considered. He was not just anybody. He was one of the best known mechanics and steam engine engineers in America at that time. And then, the next year, with all the money he got from Lowell, went to England and did very much the same thing and invented another kind of lock over there for banks and stuff, and was knighted and all kinds of stuff. So, he made it big in England. We don't know much about him, remember much about him here, but then you get back to William Gilmour, who, I just got to throw him back in there. He, like I said, was paid $1,500 by the Rhode Island mill owners to not patent his loom. He ended up bankrupt and in prison in Providence for debt, and as far as I can tell, died within a month after they let him out of jail in 1820. And but he was a real engineer. He's the one that brought the design for hydrostatic press, it was called then, but it's a hydraulic press. So the hydraulic press was invented in England in 1796, 97. So this was like only a couple of teens years old when he came to America and taught David Wilkinson how to do it. And he tried to patent a revision of his loom. And yesterday at Baker Library, I saw where he paid the Providence Iron Works to make the parts for it, for his new patent, but I never found anything where he ever made any more of them. So I don't think he didn't have any takers for his new patent. So these looms, Gilmour loom, iron frame, drive shaft, and a crankshaft, positive drive, the lathe hinge at the bottom, pick motions of crank, shuttle protector, shat harness, and Waltham loom. The frame is wood. Everybody says it's wood. It only has one shaft. It only has a camshaft. The lay is tripped by a cam, and the beat up is made with a spring. The lay suspends from the top. The Gilmour looms hinge at the bottom. Pick motion by a cam. And so you see, I mean, this is not a very adequate description of either machine, but it's all we've got when you look at, the actual hardware. So, just the things that you see there, the frame of wood, only one shaft. This is what the loom looked like that was used in this building to start with, from 1814, 15 to maybe to 1827 or 25, because there's a record that says the first crankshaft was added to a Lowell loom in 1825. So I think the very first loom in this building would have looked more like this than that one out in the hall. And, just it's got the same things. And not like this. Now, on one of their exhibits out there, they show this because Mike Folsom of sainted memory, helped find these documents, Isaac Markham, at Sheldon Museum in Middlebury. And they're a treasure trove of this young man who went around. He worked for the Boston Manufacturing Company. He made all these drawings of machines that he saw because he wanted to open his own shop and make machinery. Well, of all the drawings in his book, David Jeremy co-authored that, only one of them looks like this, and it's colored silver gray. The rest of them, if they're colored sort of tan colored, and the mnemonic there is that tan is wood and silver gray is iron. Well, this can't be a Lowell loom, despite what it says on the exhibit out there, because it's made out of iron. I think, if anything, this is what one of the Gilmour looms looked like. So, that you get down to it. You've got the Horrocks loom, the Gilmour loom, maybe. You see how similar they look. Everybody, the worst misapprehension in all this is everybody tends to call this the Scotch loom because Gilmour came from Scotland. But it's the Lancashire design. The Scotch design is the wood frame loom. So the loom in common use is more Gilmour than Lowell. And the drawing out there, 1827, a great representation of what the Lowell loom looked like after they started adding the crankshaft in 1825. So you see, it looks very similar to the Gilmour loom, except it's still made out of wood. So, Lowell Machine Shop, this is one of their designs in the 1840s from a cloth label in the 1840. And, it has merged the Gilmour and the Lowell designs. So this is my last slide, but, I got to say, none of these guys did it alone. The Joseph Taylor, who is the clockmaker machinist in Manchester, was Cartwright's joiner and engine maker who helped him design his loom and made it a reality. William Horrocks, he had a mechanic called Higginbotham in Manchester and had these professional foundries, Ormerod and Peel and Williams, build the looms for him. Lowell had Jacob Perkins and Paul Moody, and William Gilmour had David Williamson. So all these guys, if there's loom history at all, they talk about Cartwright, they talk about Horrocks, they talk about Lowell, they talk about Gilmour, but their engineers are really just as important. And textile machinery is what basically invented the whole profession of mechanical engineering. And Columbia University says the role of mechanical engineers is to take a product from an idea to the marketplace. And this building is where an idea came into being in an actual marketplace and transformed, the textile business in all of America. So, it's kind of the temple of textile history here. And it's been a long, strange road here, but I appreciate you asking me to come talk about it.
Thanks, Mac. I'll have some draft signage to email you soon. If anyone has questions for Mac, I wonder, Mac, if we can put up the image of the one with the high castle that is.
That one?
So that's what you say is similar to what could have been here.
Well, that's the one he had to see. If he copied one, if he memorized something, if he was everything they said, that's what he was looking at when he did that. Not the other one, because the descriptions of the other one don't match what everybody says his looked like.
And it looks suspiciously like the one in the seal. Kind of.
Yeah, close as you can guess. I mean, the seal doesn't tell us a lot.
Can I have any questions for Mac? Wait till I bring the microphone over.
When this mill closed down, was it using antiquated looms?
This building, no, from the pictures that Steve and I looked at today, they were actually using Crompton and Knowles looms. So I'm not sure exactly what their product was when they shut down, but Crompton and Knowles was one of the only surviving loom makers that weren't put out of business by the Draper Company, because they made pattern looms who wove multicolors, like any plaid or stripe, has to have either the stripe is in the warp or the stripe is in the shuttle. And C&K looms had a mechanism to stack the bobbins so you could have multicolors and change, and didn't have to rely on the Draper battery. But as far as I can tell, it was C&K's here all the way, and they were made, Crompton Knowles were made in Worcester, right?
So this company was still investing in new machinery into the 20th century.
Yeah, well, textile mills had to, you couldn't, well, a lot of mills used it until it totally wore out. And my mill in Franklinville, when it closed in 1977, they were still using Draper E models built in 1915. And to some degree, that's a testament to American manufacturing, that they were so sturdy that they lasted that long. There were disposable parts on all these machines, wood parts and leather parts and plastic parts, and you could upgrade them. But they kept old things running a long time. Now, this loom would have been so clunky. It probably wasn't that fast. 70 picks a minute probably was top speed for this. And I think the Gilmour loom could probably go faster than that, maybe 80 or 90. When you rely on the spring to thump it back, that sort of limits the speed you're up to, because the spring, you got to go back and forth. And it's interesting. I mean, and it worked. It worked. But as I've said to Steve, and I could see the hurt in his eyes when I said, the Lowell loom was an inferior product. It was superseded by a better design, because they actually incorporated everything good about the Gilmour loom into their designs by 1827. So they knew it wasn't, it could be faster, it could be better, as long as, they didn't have to pay anybody else for the patent.
Yeah, so just if I make a few historical points, then I want to ask my question. So you're absolutely right with the C&K. Compton and Knowles specialized in looms that could do complicated fabrics with multiple colors in there.
Boxes, yeah.
In contrast, Draper specialized in high speed. The final generation of their looms, the shuttle looms, I think top out about 220 ticks per minute. So they
That's
faster.
the X2s and X2 and X3, yeah, they were the
Fastest of the shuttle ones. And that's also why you see the Crompton and Knowles had these very complicated mechanisms for changing the shuttle. Each shuttle would have a different color.
No, each bobbin would be different. The Stafford loom had a magazine that changed the shuttle. There were all kinds of, these companies tried a lot of different ways to get around the Draper patent. And so,
Big patent thicket.
yeah,
What I wanted to ask about though was the role of metallurgy in this, because if you think about it, the number of cycles that a loom goes through is enormous. So the cyclic stress applied on a spring, considering the very primitive state of metallurgy at the time, would have meant that you had to probably burn through a lot of springs. And when a spring fails, that's a pretty nasty thing. In contrast to crank loom, with its positive action, is not as sensitive to the metallurgy of the spring. And I think the role of the cyclic stresses is why those old Draper looms are so heavily over-engineered in cast iron, because when the cast iron part is sufficiently thick, it doesn't fatigue
right,
anymore.
right.
So now, over the last centuries,
But the interesting thing to me doing this research is that the Horrocks loom was the first machine I can find in England with a cast iron frame that wasn't a lathe. The very first machine with a cast iron frame was Maudsley's loom, 1797 or something like that. But in 1803, Horrocks was experimenting with an iron frame loom. Nobody had ever built a machine with an iron frame before. And it's also interesting that when Gilmour comes over, his machine is an iron frame. Nobody in this country had ever made an iron frame machine before. And it's interesting to me that Horrocks and Gilmour basically had to encourage people to take a leap to metallurgy, like you say, that to do something nobody had ever done before. And I can see a lot of people would say, why not keep the wood frame? Wood's just as good, and it's cheaper, and it's easier to put together and stuff like that. But actually, David Wilkinson sold a Gilmour loom for $60, and the patent on the Lowell loom was $300.
Yeah, I was wondering, so with all your exhaustive field work, is the Asseltine loom the oldest surviving loom that you've found so far?
Absolutely. Yeah, I've never seen an existing one, anything like it in this country. I mean, no other loom in this country I've ever seen had this center pick. And that was, at that period, that was, the state of the art.
And do you know what wound up where you found it in?
Well, Mr. Asselstein started his woolen mill in like 1860, 61. And according to them, there's not a lot of records, but according to, it was up there in upper Canada, Ontario. And he bought all the machinery in New England. And obviously the wide loom is made in Philadelphia. This one, I think, was made in Stafford, Connecticut. So, yeah, I mean, I don't see anything that says he didn't buy all his machinery, except that one loom from Canada, which they don't even exhibit.
I just wanted to go back to the hand assistant that you mentioned that William Gilmour sort of went towards.
The which loom? Which loom?
It was not a power loom. He's the guy who was focused on event everything, but he had a hand assistant.
Oh, yeah. The Radcliffe loom. Yeah.
I was wondering what was the the mechanism of the loom, or what part were they trying to mechanize? Just seems like interesting in between balance decision.
Yeah. Well, have you ever heard of a Hattersley loom? Hattersley. That is, I don't think it's still made, but they're prized. I mean, if you can find one in England, it goes for a lot of money, and it basically is operated by your feet, sort of like a pump organ. You know, you're using your feet to make the motions happen, and you still use your hand a lot, but to make tartan or wool tweed, you don't want power, because, like I said, the wool yarn is very fragile, and you could easily break it. And so doing it by hand is much the better. Now, certainly C&K had woolen looms, but you know, if you're just crafting, a Hattersley loom is still the best way now. I mean, the tartan weavers love it.
The Harris tweed has to be woven by hand, so there's a market for a few of these vintage. It's basically a mechanical loom that instead of being powered, you know, with a belt from a motor, they're just basically a bicycle mechanism and pedal.
Yeah, it's got all the stuff. It's got the crankshaft and the camshaft and the stuff like that, but you're just pumping it with your feet to make it go instead of, you know, a crank like a weg beater.
Quick question. The looms, when they came in around 1800, were they in England and in Scotland? Were they primarily making wool fabric?
No. Wool was done by hand. So all of these basically made cotton sheeting or shirting, depending on the fiber, the strength of the fiber you're using. I mean, if it was heavy duty, I think you called it sheeting. If it was lighter, you call it shirting. But it was plain weave. Both these looms made plain weave, which is just crossing back and forth. And twill, they could make twill, but you'd have, instead of 2 harnesses, you'd have to have 4 and stuff. So, yeah.
Did they also do the bleacheries?
This mill did, yeah, bleachery right down the river, yeah. And the ones in England did too, although everything in England was a separate business. So in England you had spinning mills, and you had weaving mills, and you had bleacheries, and they were not necessarily owned by the same people. You'd spin your yarn, the weaver would buy it and weave his cloth and send it over to the bleacher, that's probably the number one innovation that Francis Cabot Lowell had coming in this country, and put everything under the same roof, because that's vertical manufacturing, right? So that was his real innovation. And you know, we always tend to say the machine was, but it's the whole business process that was. I mean, this is the first stock corporation in Massachusetts, right? My mill in Franklinville was the first stock corporation in North Carolina in 1838, 20 years later. But you know, we forget how new all this stuff was.
So I wanted to ask, around here, in the after 1870 or something like that, a lot of cotton mills converted to wool. And when you read the descriptions in the history of this, how they upgraded or converted, in that case, would they have to remove the previous equipment and put new equipment in, or was it possible to just swap some parts and adjust a few things, something like that? There was a lot of that conversion as the cotton business left and the wool took over.
I think they would have had to get new machinery if they were making that kind of conversion, because the preparatory machinery for wool is very different from the preparatory machinery for cotton. You know, cotton comes in bales, wool doesn't. Wool has to be scoured and this and that and the other thing before you can use it. I mean, Cartwright, actually, he didn't make much money from his patent on the loom, he made a lot of money from his patent on a wool comb, which is a step in the process of wool spinning and weaving that I haven't even attempted to try to understand. But it was a lot more successful in England than the loom.
Curiosity question. When did the mills in England and Scotland become vertically integrated?
In England, it probably wasn't until the 1860s, and because, like I said, they were their process. They liked the fact that everybody was separate. Now, I think it was earlier in Scotland because the same rich guys owned all those mills anyway. So it's just a matter of putting them all under one roof. Now, the limitation was, I think, water power, because the more stuff you had needing the same belts and everything, that used up all your water power. So it was probably a lot easier to have one mill with one wheel or one steam engine for each process.
Mac, thank you very much. Thanks for coming on, everybody.
Thank you.